Hello, class. Today we're going to continue on our topic of random variables. And today we're going to just talk about transforming random variables. Um, yeah. Remember, if you haven't been bringing your books, you want to make sure that you bring your books for the remainder of this week because I believe you will have in class time to work on problems. Probability, the most important thing for you to do is to practice and to check your answers. So please use your in-class time wisely. All right, cool. So today our main topic is going to be transforming random variables. Okay, so yeah, we're just going to talk about how do we transform. So again, we're going to be going back to chapter 2 where we talked about transformations in general, right? And the same rule applies when it comes to random variables and probability. When you add or subtract a constant to each observation, right, it affects your measures of center and location. But it doesn't affect your measures of spread. So like IQR, range, standard deviation, and it doesn't change the shape. Yeah, it just doesn't change the shape of the distribution. Okay, so when you are multiplying or dividing by a constant, then um, everything changes except for the shape, right? The measures of center and location and the measures of spread also change. So the same rules apply for random variables, okay? So let's go back to Pete's Jeep Tours, okay? Um, let's go back to that from the other day, okay? Um, and so if we look at the distribution, sorry, I'm going to move myself away from where you can make sure you can see. So this was the distribution that we had, and we calculated the expected value the other day and all of that stuff. Okay. But now we're going to add kind of a wrinkle, right? Let's say it costs Pete $100 to buy permits, gas, and a ferry pass for each day trip, right? So that cuts into his profit. Okay. So instead of, you know, like instead of making 300 for two people, he actually only makes 200. And then, he has to subtract 100 out of all of his profits, right? Well, what's the main difference here, right? The main difference is, the graph just kind of shifted downward, right? The mean ended up being, 462.50. But, I'm pretty sure if you just eyeball it, you can see that the standard deviation is not going to change, right? It's still going to have the same like variability, right? Um, if you really need to, you could redo the calculation, but you're going to find that it's going to be the same, okay? The shape is the same as the original function as well. So the rules, are the same, right? Like when it comes to probability distributions, if you add or subtract um, like a measure from the probability distribution, right? It changes the measure of center and location, like median, quartiles, percentiles. However, it doesn't change the shape or the variability of the distribution. Okay. Okay, so let's take a look at this problem here. In a large introductory stats class, the score X of a randomly selected student on a test worth 50 points can be modeled by a normal distribution with a mean of 35 and a standard deviation of 5. Due to a difficult question on the test, the professor decides to add 5 points to each student's score. Let Y be the scaled test score of the randomly selected student. Describe the shape center variability of the probability distribution of Y. Okay, so pretty much what you can say, right, um, is that the mean is going to be what, 40? Okay, and the standard deviation is still going to be 5, and the shape is still going to be normal, right? Just based on what what we had just said, right? The shape is not going to change, approximately normal. The mean, you're just going to add the constant 5 because you added 5 points to each score. And because the variability doesn't change, it's just an upward shift, you would get the same variability of 5. Okay. Now, what if you were to multiply or divide by a constant? Going to be the same rules, believe it or not. It's going to be the same rules, right? So let's just actually see how, like an example of this, okay? El Dorado Community College considers a student to be a full-time student if he or she is taking between 12 and 18 units. This is like, I guess you could say hours of classes. The number of units X that a randomly selected El Dorado Community College full-time student is taking in the fall semester has the following distribution, right? So, um, 25% are taking 12 hours or 12 units, 10% are taking 13, 5% are taking 14, 30% are taking 15, so on and so forth. At the right is a histogram of the probability distribution. The mean, which is the expected value, right, which is calculated for you, is 14.65, and the standard deviation is 2.056. At El Dorado Community College, the tuition for full-time students is $50 per unit. Okay, so hopefully you see what this is getting at. That is, if tuition is a charge for a randomly selected full-time student, is going to be 50 times the units, right? So you should be able to see that we're probably going to be looking at, okay, well, what's the transformation here is instead of number of units, we're going to be looking at the expected cost and the variation within the cost, right? So if you were to find, the shape, right? Well, the shape is still going to be, um, roughly symmetric with three peaks at 12, 15, and 18. But the mean is going to be a little bit different, right? You're going to have to multiply your current mean by 50 because the average is 14.65 hours or units. And then since it's $50 per unit, then you would take 50 and multiply it, and it would be what? $732.50. That is your expected cost. And then your variability, because your variability also changes, right? Your spread is going to change. You multiply the standard deviation by 50 as well, and that's how you get $102.80. Okay? All right. That's actually it for today. So please spend the rest of your time doing some work, your homework, and I've actually covered what I was supposed to cover in 10 minutes. Crazy how efficient you can be if there is no back and forth. See you soon.